we might as well start. First of all, I would like to thank our sponsors, which are New Relic and Develandoo. I would like to hear very big applause for them because of them this event is possible today. So let's hear it. Why we are here today? We are here today to find out why monitoring of data is actually important for the businesses. What do we expect from that monitored data? What can we do with that data? Should we do it? Okay, when we do it, so what do we expect? What are the final definitions of that data? What are we looking at? And all those questions and more we're expected to hear answered by our first lecturer, whose name is Harry Kinkle. Harry, please give it up for him. So, a few words about Harry. Harry has a working experience with development background for more than 20 years. So he's been creating custom software solutions for customers around the globe. He has worked in cloud architecture and cloud migrations for many, many years. Sometimes his work feels more like software archaeology, especially when re-architecting legacy applications. Please, give it up for him.
All right, so welcome everyone. Pleasure to be here today. Thanks for the introduction. So I want to give you, firstly, I start the mic, and I hope you can hear me now better. So firstly, I want to give you some perspectives of how you can leverage monitoring, data from your monitoring to make actually better business decisions, and how to get there from just like looking at technical metrics, but also more on how we can define business metrics out of that. So like you said, I'm Harry. I work for Relic, and been basically there for like the last 2 years. And from a pre-sales perspective, so I work a lot with companies on the technical perspective, getting things up and running, evaluating things, doing workshops and stuff like that. So anyone watched the Super Bowl game on Sunday? Anyone? Yeah, the right team won, right? So you imagine, you sit there with your friends, watch the game, and suddenly, like, the lights go out, right? So the game is gone for you. Of course, you're sad and disappointed that you wanted to watch the game with your friends, have beer, snacks, and everything there. So of course, you're disappointed. All your friends are gone, and then you suddenly call your, power grid provider, and they tell you, why are you complaining, right? The service was available for 95% of the time, right? We don't offer you 100% of the time that your service is available, right? So we need to think about why this is important to monitor all your environment and what to do when things go sideways. Services will fail, and they will fail always, right? There is no thing as, hey, I can rely on that my service is always available and visible. So what I would like to do is kind of like give you, 5 different perspectives on how you can leverage the data from monitoring to make better business decisions, and basically also focus on trends and future aspects that you can derive out of that. The first, the key is kind of like how can you improve the problem occurrence in the first place, and how you can work on getting to the root cause analysis of why this is happening, right? So if you want to make your decisions, you need to know everything that is happening in your environment. How do you do that? Basically you want to proactively assess all your environment. You want to know everything that is happening in the end-to-end infrastructure. That could be services, it could be infrastructure, it could be dependent services that you're monitoring. And you want to know how your services are performing, right? You want to know whether dependencies you have, firstly, know what these dependencies are, and basically then know when these dependencies, your services are not available, right? As we've seen in the Super Bowl game, you want to measure everything that is happening and want to make sure that your SLA is always there for you. Finally, you don't want to actively look at that data. Ideally, you want to get notified. Proactively get notifications when things go go sideways when things are not performing as expected. This is, I have two examples from our own environment that I wanted to quickly share with you. So this is one of the services that we provide. It's an account service. So basically our customers can go in there, look at their account data, and look at basically all the other accounts that they have access to. What happened is that there's some avatar on that page for the user. It could give you a nice image. And at some point, that avatar service that we depended on was a third-party service went down, right? So we developed that service back then in a way that once that dependent service is gone and it is not available anymore, our complete site crashed and it wasn't responsive anymore. So basically, just by looking at that single icon, it's really not an important thing on the website or in the account page, but it caused the whole page to go down, which is really not ideal. A second example is kind of like, again, the account service that we were looking at. The problem there was there was some user who was exiting that page, like he asked for, give me 100,000 accounts for my data. And basically the service, it tried to be responsive and kind of like work on all of this data, get all the account data back. But at some point it just crashed, it was too slow, the site went down. And so basically that request that was really not really reasonable to get like 100,000 accounts, but it caused the whole service to go down and crash the whole application. So basically, it's important to know when things are not reporting and having performance problems. So you want to be aware of everything that is happening and work on these items. Second key, from my perspective, is kind of like you want to be aware of every interaction that is happening. Not only from a technical perspective, but basically you want to know, when your users, how your users are behaving, and want to proactively get alerted before your users actually notice what is happening. Why is this important? So basically, if you don't see every interaction on your application, every interaction on your services, you might miss the important ones, right? If you do some sampling, or you think, hey, maybe if I look at 80% of the data, I will probably be fine. But maybe in the rest of the 20% of the data, maybe that is something where important information is missing. You want to know your users. It's kind of like a sensitive topic here in Germany. What I mean with knowing your users is kind of like not knowing PII data, but knowing how your users are using your services. What type of device they use, when they use the service, kind of like, look at that type of data and know how their behavioral patterns look like. And again, you want to set up checks for all of these different types of information. You can get alerted on when your users hit certain limits, or when users are using maybe some features in your application, that you want to be also notified if anything important happens in your services. What are the benefits? Basically, once you do that and you know how your users are behaving, basically how your audience looks like. What type of user, the personas, the type of users, how they act with your application, and you can then use that information to predict behaviors for future. And we'll see a couple of examples later today. What you can also do is kind of like generate trend reports and look at patterns on all these technical KPIs. So this is really just focusing on the technical KPIs, which will help you then to make decision making basically in real time. So once you know how to get the data and how to process the information, you can make predictions for future behavior. The third key is kind of like, why should you monitor your environment? Well, one of the reasons to do that is also kind of like mitigate risk for your application. Basically, there's risk in all different kinds of services. Maybe there's risk that your host will go down, that the database will not respond. All different kinds of risks that are involved. And risk is basically a measure of likelihood of surprise occurring. You want to basically remove the this level of surprise. keeping a system available means to remove risk and hence removing surprise in your application. But as with nowadays, these systems get more dynamic, they scale up and down, and the bigger they get and the more services you have, the more complex it is to have kind of like visibility into all of this. So basically, you want to ideally work on risk management, and this is kind of like in the heart of providing these high available systems for your environment. So let's focus on the risk mitigation for a second. Basically, you want to know what to do when a problem occurs, right? So you want to reduce the impact that it has, and you want to also make sure that the application works as best as possible if anything happens. And then, of course, more importantly, you need to have a plan in place. If something happens, what do you do? How to inform people? How do you your support teams and the operation works and can remediate everything that is happening? So that brings me to the fourth key for this, which is kind of like monitor availability and the response that you provide to your services. What you want to do is kind of like understand how your applications and your services are performing. You want to ideally use application monitoring to keep an eye on everything that has happened with the application, how it is performing, generate notifications and things like that. And ideally not have that measured on hard facts, but basically having the baseline in place. So basically if you know how your application is performing over time, maybe you have some pattern that looks like on Monday to Friday you have like a certain load on your application and then it goes down on the weekend. This baseline is kind of like important for your applications if you want to know what is happening and also predict behavior for future responses. So and then the responsiveness is kind of like, if a problem occurs, you need to have a plan in place on how to fix that problem. Does anyone on your team know what to do? Do you have plans in place or playbooks? Basically what we always try to suggest is kind of like having a run book in place. If a certain error occurs, this is what the steps are required to do. This is what what systems to look into, what services to monitor and things like that. So everything is kind of like important, but you should be preparing this before anything happens, right? You need to have a well-established plan in place, document the processes, know whom to contact, maybe have other services in place that you can look into and have kind of like that chain of responsibility in there. Oops, sorry. That also brings me to the last key for this topic is how can you make sure that not only the technical KPIs and measurements are in place, but also your business KPIs, right? So this is important because typically all your services that you provide, all your applications, at some point they have a business reason, right? And ideally, what you need to do is kind of like have KPIs in place so that you know what to measure. And typically the hardest part is how do you define your KPIs? You need to know where to get the data from, right? We can derive a lot of data, business KPIs from the technical information that we collect. But basically, maybe if this is not enough, you can customize that. Maybe you need to have additional data points, additional events that you need to capture, and then this will help you then to basically create these KPIs. By doing that, thinking outside of the box is always helpful. Don't have that siloed focus on different services, but maybe have the whole interaction chain in mind to think of. And the last one is don't get trapped into the tech jail. Basically meaning that yes, I guess we are all techies, right? We love technology and things like that. You have to look at services and monitor things. But basically, if you think outside of the box and think of like in the bigger picture, you can basically focus on the business that these applications and services are targeted for. Once you have defined your KPIs and your business metrics, you don't want to create the metrics every time again and again. So basically having a standard set of dashboards in place to visualize the information automatically. Ideally in real time, to have access to that, having a dashboard in place that has all the important metrics in there for you to look at. What we also try to focus on is kind of like democratize that data. Data shouldn't be there just for one single person or for a single group. Ideally, everyone should have access to the same set of data and can work on that and create their own maybe custom dashboards. This is important that, first of all, that finger pointing is not happening, that one team says, hey, my data shows green, your data shows some red information. So basically having all people and responsible persons looking at the same set of data is kind of like key. And basically from there, you can basically say trends and make real-time decisions on that data. This will also help you, with some of the customers, they have kind of like these game days where, they look at data and compare teams with each other and things like that. So there, you can be creative in how to leverage that data that you collected and visualized in such dashboards. And also finally, if you received certain business KPIs and you measure those, celebrating success is kind of like also important. So in summary, these are a couple of key things to look at when you try to use the data from the monitoring to build technical KPIs, build business KPIs. If you want to remove risk from your environment and surprises, this is kind of like some key topics to focus on. The question now is, where does this data come from? And I wanted to give you a quick overview at the end to show you, what we try to get is and this is what I also mentioned earlier, we try to get like all of the data, right? Not like single interactions into silos, but basically focus on the whole journey and the chain that a typical user interaction goes through. So that could be, information that comes from devices, could be information also that you use from social media, where you can do some sentiment analysis and have that reflected also into your environment and having performance benchmarks against those sentiments, maybe having data from the servers, the hosts, the databases. All these services will then have data into one bucket, and then you can start doing some analysis, building the technical as well as the business KPIs. We'll see later on in the next talk some use cases and how Andre uses this type of data to actually do some analysis and work on some AI patterns to actually analyze the data. But basically what I wanted to mention here is that the type of data that he received from us as a sample is kind of like not like all of the environments, all of the chain, but really just from a single environment. We were just looking at this kind of like device data, and I think you'll be impressed in what he achieved with just looking at the data without any further input from myself. So this was really interesting. And then finally, I wanted to provide a kind of like a use case from a real scenario. And this is one of the customers we have, and you'll be surprised in what they kind of like achieve. And I wanted to give you just this perspective on what's possible. It is not really only just data that you can collect from business applications or technical environments like databases or stuff like that. So this is really just an example, and I'll start the video here. This is really just an interesting topic. If I can manage to start this. No. Let me stop there. Sorry about it. Okay, move it over. So this is a retailer in the UK that actually uses our data to collect all these data points from all these robots. So it's basically a huge warehouse without having a kind of like a retail store, what these robots basically do is they put products that the users can buy online into these carts, and they walk around and do things, collect the data, put this in the basket and stuff like that. What is interesting about that is that the company leveraged the data that they collected to find out that in some parts of that whole factory basically it was just not used, right? So they had like a third of that factory not being used, and these robots couldn't get to that point. And with looking at the data, they found out about this issue and solved it by changing some configuration here and there. But basically, having the visibility into the data and doing something that is important for their business was key in solving that issue, and it basically saved them a good amount of money, because that data warehouse in that region was just not responding to requests. So really, and one example use case that I thought was interesting for this approach. So yeah, that was basically my talk. Thank you very much. Do you have any questions? Do it at the end of the... Yep.
So thank you very much for the presentation. It was very intense. You said that monitoring availability and availability response. But what's the difference to risk management when you describe around the uncertainties and how you mitigate them? What's the difference between availability and availability response and risk management?
Right, so availability monitoring is kind of like having tools in place to actually monitor everything that is happening, right? Knowing when your applications get requests, whether they fail, do they have any dependent services and things like that. So having all the data available for getting the information in the first place, and then monitoring, in what type of environment was my data available, right? So looking at the SLAs basically, the response is kind of like knowing what to do if errors occur, right? So if you have some, like the example before where the avatar service failed, knowing that information and knowing what to do with the data is kind of like the responsiveness in having a plan in place, and this is what you need to do, this is what you need to follow, this is a run book for this specific issue that you need to follow.
So you simulate the report cases or something like that?
You can do that, and this is what typically customers do proactively. So they have proactive monitors in place to check certain services. But you can also have these playbooks in place for things that occur. If an application response isn't what you expect, you need to know whom to contact, who's responsible for certain services, and then going deeper into the chain on how to make that root cause analysis.
Okay.
Does that
we are all risk management, but it's fine. I understand the principle.
Okay.
Thank you.
Yeah.
So in your presentation, I've seen that there can be multiple users using desktop, mobiles, and so on. And is a solution that can match different users using different devices? So for example, match customer using mobile phone and the same customer using desktop.
You mean like the question is related to can we correlate that information from the same user?
Yeah, to understand.
Right. So you could basically, out of the box, at least the Relic doesn't collect any personalized information. So you could, if you have the user ID, for instance, know that it's coming from a mobile device or it comes from a web application, right?
Yeah.
But if you don't have this information, you can add maybe some technical, user, not user IDs, but maybe some IDs that that allows you to make that reference to the user itself, right? You could basically use a hash on the user ID to follow that information and know then that the user came from a mobile device or came from a web application. Does that?
But in this case, user should be registered in the system. Get this hash, right? That's what you do not register.
Right. So if you don't register it, basically out of the box, we don't have any capability to correlate this information, but there are ways to enhance it. There's APIs in place and how you can add additional information. And one of the things could be to have a hash over the user ID to know and have that correlation point, if that makes sense. But out of the box, you know, you would have to have one correlation ID that you can leverage to get that connection right.
Yeah, it's correct if I'm wrong, but I think I heard the company name when Simon Brooks played with lean startups. Is it correct? Or
With
lean startups.
Lean startups.
Yeah.
I mean, the history of Relic is basically coming from the startup environment, right? And since a couple of years now, we focus on business, but yeah, it could be the case that this is where it's coming from. Yeah.
Any other questions? Thanks, Gary. Thank you very much. Okay, 20, I think. Wow. Okay. And he's a lead data scientist at Epica AI, and a software engineer, entrepreneur, owner, AI and big data research team, and consults about AI adoption in digital marketing, also e-commerce, and text processing, right?
Yes.
Perfect.
Is it fine?
Yeah.
It's a pleasure to see you all here. Thanks for coming. I'm going to talk today about making predictions over customer data. And the whole story about this meetup was that New Relic gave us some small sample of information to see what we can extract from this information. It's all about customer data. And so I had only one weekend to try to do something, so we didn't ingest this data into our platform, Epica. And so I'm gonna tell you how we process data in Epica, typically for customers, and then I'll show you how it is possible to analyze customer data, for instance, from New Relic, to understand what kind of value it is possible to extract from there. So this is the whole story. And then my colleague, Andres, will talk about about the use case, how we achieve, like, how we improve CTR for one of the big publishers in Spain, for instance, with this approach. We thought that this might be interesting and relevant for today's story. And so basically, this is the structure of my presentation. So I'm going to tell you a bit about Epica. So I'm the VP of data science at Epica, and you can check what we do and contact me anytime, any questions regarding this. So this is the only marketing slide I have because Develandoo asked me to make a technical presentation. So believe me, customer data is important. I guess everybody knows, and this is a big deal. This is a $1 billion market. There are a bunch of vendors. Everybody tries to improve conversion, like whatever possible ways. So you have to take care about this today. First, everybody knows the CRM approach. It's pretty straightforward. You have a customer profile, and you fill it with some data sequentially. Modern CRM have automation tools to connect with some different sources, and this profile could be filled automatically. But at the end of the day, this is like step-by-step process. But what happens now? So we have a modern customer journey. If somebody wants to buy something, he makes like very complicated paths through different websites. He tries to explore, ask, research, browse again. And the whole idea is the following. What if we can collect customer profile from this complicated journey online on the website and completely automate? So how we can approach it? Of course, checking pixels. This is the well-known story. Google has it, like Facebook has it. Our tracking pixel was inspired by a segment. This is a customer data infrastructure. This is how they call themselves. And basically, if you already know it and use it, we're probably going to talk because we can offer
good integration with that. But this is just the top of the iceberg. But in the bottom of the what we have, we need to make a cookie matching because we need to collect this profile from different sessions, from different devices. We need to have certain precision on this process, and we need to integrate third parties. For instance, we can match with DSP systems and understand what is the ID of the customer. This might be the answer of those previous questions, how to match users. We need to filter bots because there are a lot of bots, everybody knows it, and we need to remove search engines from customer profiles, some synthetic requests, some parsers. And basically we need to build a reliable architecture, which is today called like Lambda architecture, with streaming, batching, low latency, fault tolerance, so with seamless integration, deployment. The whole product should be totally reliable, and this is the big issue. You can imagine how it might be like complicated technically. I may probably say that we received successfully 40 terabytes of data only in January 2019. So last month. So this is one part of the story. This is how we call it, like event sourcing. Well-known pattern in the big data technical. Another step of this process is to materialize these events into something which we call basic profile. So we have all those events, they are differently structured, they have a lot of metadata, devices, browsers, user data. And basically we process these in order to store, first we store our basic profile in the relational database. We still use Postgre, but now we're switching into graph database because it's really crucial to match those profiles fast and reliably. So this is what we use for this purpose. If you're from big data world, I guess you know those things. And then you may say, let's predict something, but not really. So first we need to enrich those profiles. Basically, this is one of the popular requests beside like predicting some conversion or whatever, is just to make an enrichment because obviously we have a limited information coming from events, and some fields might be missing, but we want to know this information about all customers that we have, if it's possible. So there are a couple of things we can do. We can integrate with CRMs, because obviously this is like the root approach and they have a lot of data about it. We can ingest well-known CSV and Excel files to make. Also we have a partnership with Oracle Data Cloud, which was a BlueKai before, and basically we can integrate with BlueKai, and BlueKai could provide additional information which we don't know about our customers, but they know. From different sources, they have a lot of information. We can even go there and ask what do they know about you. Like a simple test from cookies, from your activities somewhere. Basically, so after augmenting, and we use prediction definitely to, if we have partial information, we could try to fill the whole data with this information. It shouldn't be really precise as you expect. It's enough to just to remove unknown data to make second part of this process more accurate. But anyway, this is important just for itself. Knowing more information about customers is better than nothing. And we come to the core theme of our platform. This is cluster builder. We divide our, what's the benefit? So we got this big amount of customers. How are we going to treat them? The core concept is cluster. So we take groups of customers to satisfy some target. We may do it descriptively, like we may track some topic viewers for instance, by URLs. We can extract information from URL and make a decision that they like browse some shell information. By some actions, like did specific actions or subscribe something. And finally, we can predict potential new buyers, which haven't done yet any of those actions, and or content viewers, for instance, and those clusters we can use to get better conversion in the end. And this is very important. We can process anonymous data. So imagine you have to identify, you have to, like in your CRM system, you have to know phone, email, I don't know, name, last name. But here we can just use a hash, and that's all. So we collect information over this hash, and we can work with this information to get like better profile. We can build a customer journey, and we can predict for this hash something and show him something that he might be interested in, he or she, and use this without like violating any of those GDPR and all this stuff. So I think this is really crucial in this case. So predictions, yes, we can do predictions. If you are from this data science world and you heard cluster, you might instantly imagine that we do some unsupervised prediction. Yes, we do, but it's like limited. The only story that we have for this unsupervised prediction is to split big clusters for some reason. I mean, if you don't have the whole budget to cover all those people, or you want just like operate less clusters at the end. So unsupervised machine learning we use only for limited number of cases, just to split big clusters into small ones. What is really important is that next, what we are trying to predict is who is going to make an action in the future to conversion. So we use decision trees here extensively, and this will be a part of my example of processing new Relic data. So I don't want to stop on this really now. But if you're from business world, just let me explain a bit that decision trees really, how do you say, makes decision. They split like the whole data set into smaller chunks based on your features, like on gender or on some other class, and based on some metrics. This is the first process, just splitting. There are several metrics to control the quality of those splits. And then those trees are pruned to make a decision, like what is it possible, for instance, to make a decision in these node or in the other node. These decision trees, I will show it later, gives very good opportunity to have decision interpretation. So you always know what was the reason of splitting those data. And you also can use this information to build a cluster over it, because those trees are accessible. Typically, methods using decision trees are quite complicated. They use a lot of parameters, so you can control all those processes specifically. That is why it's tricky to use. But finally, this is not something which is called carbon competition. You don't need to find very precise or very good accuracy here in the marketing world, because you need to keep in mind the balance. If your clusters would be super precise for clickers, for instance, it would be hard to run marketing campaigns over those clusters because they're too small. I mean, people from marketing world, they need to use clusters big enough to cover many people day by day, rather than wait someone who is highly to convert the whole week. That's the challenge. But I will talk about this problem a bit later. Then we try to predict when. Mathematically, this is less complicated problem, so you just need to to get a histogram and just determine, for instance, some hour with bigger activity, or you need to do some smoothing with this kernel density estimation to determine the right time interval for making action. That's the challenge, but it's more or less easy. And the second part, we are trying to predict what customer is going to buy. This is totally different story. So I just like to mention that we have a recommender system for this purpose. We vectorize profiles, vectorize items, and do regression over these vectors. This is like a ranking problem, and I can speak hours about those recommender systems because we get a lot of experience with them. This is not only a challenge to make it working good, but you need to deliver it again in the big data infrastructure with all this low latency and all that stuff. So this is the whole story. I hope if Develandoo will ask me to make another speech, I can tell them about recommender engines, but this is not a topic for today's presentation. And finally, activation. So you have clusters, what's the value? You need to activate them. What kind of activation we offering? It's typical like advertising platforms, Google Analytics, Facebook. We use website widgets. This is like very, I think it's a strong point from our side because you can integrate recommended widgets on the website or content widgets on your website trying to forward your customer to the right decision. Then you can send data to demand side platforms, CRMs, ERPs, call centers, whatever we have or we can build an integration to, and basically just increase efficiency and achieve business objectives. Sometimes it may not work. That's true. We can't guarantee like magic. But what we can say for sure is that those predictive clusters which were built to target conversions typically performs better, sometimes like 2 times better than clusters without this special setup. So this is summary. We do data capture from different sources. We do descriptive customer journeys in clusters. This is the key point, and future behavior prediction. And we activate. And from this activation, so imagine that we need to start today processing your data, just like we tried with New Relic. And you did an export, and we ingest this export into our system and like start operating today. But after that, our pixel checks the conversion information like we wanted to see at the end, and we can use this feedback information to make our models better at the end in our infrastructure. Basically, what pixel gives us in general, we exactly know the format of data that we're trying to get. Imagine that if you try, this is from my consultancy past, you come to another company and you get one data structure. You come to another company and you get another data structure. And this is hard to put like everything in some automated process. You need to treat each data set separately. But here with Pixel, we can we know what we expect, and we process this instantly and get results. So we already work with all of those companies, and so we use this unilever. How to say? We use this unilever phrase as a reference. So we just who is going to be our next client? We're trying to predict for them, or what your client is going to do next week, next month. Typically, it's the weather forecast is not really reliable, but it's also good. This is what I want to say about our platform. So let me show is about processing neural data. It was an interesting experience. Maybe some questions on this one. Yes?
I've seen a Walmart presentation on retail, of course, and so they use Bayesian network for causality, to predict the buying and buying patterns. So what do you think about that? And the next thing is, are you taking advantage of, for example, Azure cognitive services or other available services like available from AWS or Google? Right, instead of developing your own network.
So there are a lot of companies which tries to utilize different machine learning approaches to this problem. I mean, what I'm trying to say is that we consider, for instance, decision trees that's the point. If another company understands better Bayesian networks, they may use Bayesian networks. I think that decision trees are a bit more complicated. There are a lot of parameters, and you may play with it. And you have this kind of interpretability that I will show a bit later. Maybe you will consider this as an advantage. But I also know that some companies does recommendations with reinforcement learning, which is really crazy. I can't imagine how they operate it. But whatever, if they see value for this, I wouldn't use, for instance, some neural networks here because this is a bit different problem, and typically in classification problem trees are better, as I know. But whatever, if any other company had better experience with this, yes. So it's not a point of, it's not a point of, as I told before, this is not a kind of competition. You need to achieve business goals, and the trick is that the final metric is not exactly like accuracy or F1 or something like this. It's another. And sometimes you don't need accurate solution finally because you may break the delivery with accurate solution having such a small cluster. We replaced it. So it's tricky from business perspective. What we actually try to deliver, of course we mentioned this power of prediction because it's cool, but we try to deliver conversion. That's the point. We don't try to deliver decision tree. We just consider that it helps to achieve conversion better. But another company definitely say that their approach is good as usual. Yes, no problem.
Sorry, may I ask?
One more question.
Yeah, of course. Yeah, so actually for me it's still not quite clear how you fuse profiles from different systems.
It depends on systems. So, can you give me an example?
No, you mentioned that you can get profile information from Salesforce and I don't know, from other system and somehow you have to fuse it.
Yes, we need, how to say, we need to have an agreement, technical agreement, so that we can match IDs, hashes. So we need to be able to to exchange this information, to have a callback with our ID with another system. For instance, with this system, this is not magic. Of course, technically, this is always like ID matching and having an agreement how to do it right. And testing, actually, there are a lot of issues. Even third-party systems could have issues with their matching, and we try to face it and check it, and we actually try to be precise about this. We do different kind of tests for guarantee that our matching is actually works and works right, and it is suitable for a long customer journey. But at the end, this is this is the process of the right integration. Just like you use external API, sometimes they're not public, you need to have a deal. There's a combination of management process and technical process.
Anders wanted to say
Yeah,
something.
yeah, I
Yes,
want
of
to
course.
complement something on as Andre explained, on the tip of the iceberg is our pixel that captures mostly first party data. Even though, think of a digital asset as a website, and mostly of your visitors could be anonymous, right? It's people that go to the website but actually do not convert, do not sign up, or just go check. And another part of these digital asset users could be known or identified users. Now, we see that there's a tremendous opportunity on the first-party data, because it's actually the richest data there is, but it's still anonymous. You understand what I mean? It's still, you don't know much about that person yet. Regarding what you said of how, a person could access this website via mobile, via desktop, via an iPad. So you have 3 different identities, right? There's something called identity resolution, that ECAP solves the identity resolution issue with a prediction. What we do is we try to predict using algorithms and analysis of variables that these 3 IDs belong to the same user with a 75% accuracy level, and we predict that this is the same. So now we have not so many 3 IDs, but one, let's say, anonymous person. And we track its customer journey. And the other option is to bring third-party data, anonymous third-party data provided to Oracle Data Cloud by many data providers. And there's a process where we try to do something that is called data enrichment. Try to see if this anonymous user is man, woman, age, income level, brands that they're interested in. So you start building like still anonymous profiles of anonymous, but this helps you to improve your communications and marketing activities. So I hope that I clarified a little bit of your question. Thank you.
Thank you, Anders.
Sort of missing my idea, but it's more handy to start. So the whole story was that to get some data from the Relic, and we talked with Harry, and Harry like, look, this is the data. I can send you from a training platform, right?
Mhm.
So this is not the real data. I mean,
Yeah,
this
from
is
demo
what's-
environment.
It's simulated data.
Yeah.
Simulated data from demo environment. We tried to make it export, and I had a weekend to process it. Like, this is why I decided to do it technically. But this technical approach shows you how do we do this inside our platform. Of course, it doesn't cover all secrets, but I can explain some typical things that you are able to do with data, or that you're going to get if you're going to work with that. So I'm just, to make it fair, I will execute every piece of code here. So here is the data. I just collect several exports from my folder, and here's what we have. Like, typically we have missing data, we have some columns. I don't know what it's all about. And just like, the first thing I can notice, this is a timestamp data. And of course, I'm curious to split it into different features. Because we can take into account seasonality, periodicity, or whatever. And this is the simple way of treating it. There are some tips and tricks to make better predictions over this timestamp data, but let's check what we have here in terms of timestamps. And what is not actually constant. So basically what makes sense. And it appears to be that all of this data from the same day, and like only hour is different. So okay, let's proceed, but this timestamp is not going to give us some good insights. So finally we have 4,000 rows and 48 columns. What are they? So basically I just like, okay, so we have item, we have some card information, we have like a lot of delays, durations. I know this is a typical point about New Relic that they track these durations, and this is really important. I will show you why. So after that, I don't know anything about this. I need to check I need to check. Oh, here, lately, when I try to build the first models, I noticed that there are strong, like, that when I try to remove basic URL of action, because we will extract like the type of action from URL, I also saw that other URLs affects very, very strong in the model result, and I saw that there are other types of URLs which I need to remove from model in order to be fair at the end. So they are kind of technical, and we also don't need them. I just mentioned them like to keep the story complete. And of course, I'm going to manage NA missing values, but this is not mandatory for modeling. So you asked about these cognitive services. We don't use cloud-based machine learning services. We use H2O. This is famous framework for machine learning, and we like it a lot because of scalability. It's written in Java, it's fast, it's like there are a lot of things good about H2O. And H2O can manage MAs automatically, but in order to check correlations and to have more consistent picture, I just take care about them. Now, but this is easy, so I just determine which columns have missing values, and I just fill those missing values depending on the type. So numbers are zeros, and objects are unknown. This is where I do this. And, so let's just check that we don't have missing values after that. And let's check that, like, for instance, item edit column is treated as expected. Then, of course, we're not interested in constant columns, but again, so H2O can remove constant columns automatically. But here, if I want to find correlations, I probably don't need them at the end. So the rest is the point. Now let's put some target events. So I noticed at New Relic dashboard that all target events are calculated using URLs. So if we visit the columns, for instance, we have like browsing. If we visit the shopping cart, this is like shopping cart event. Or if I manage account, then we bought something. And actually the same approach we have in Matica, we process a lot of URLs to understand better what happened with user on the website. So I just create like to browse, new feature to browse, to see how it affects on the final conversion to cart and to check out, to separate them. Let's check correlations. Correlation table. So we have high correlation between like potential and purchased columns, and actually I was specifically interested in target variables, and obviously if we check out target variable, is highly correlated with purchased information. Definitely if I want to predict checkout query, I need to remove all this purchased information. Others are more or less fine. So as I mentioned, like I remove the source of conversion from, and let's start modeling. So I mentioned H2O. You can notice that it is possible to manage number of threads. It means to specify how many cores do I need to utilize to process this data. And I can, for instance, limit memory. So it's I have very good control in cluster what amount of resources I want to dedicate to this to the model. And let's I think it started. Let me check if I can. So I'm not going to start it again. Yes, it started. So what I do, I put this information into H2O because it's like it's a clustering solution. All data is transferred through internal protocols, and I have to put my data frame into H2O to process it inside H2O. And then I check if I'm actually like doing classification problem. For instance, with two cards, because if it's treated as unknown, then I'm doing classification problem. If it's number, then H2O would consider this as a regression. So let's prepare our experiment. Let's make two cards as a dependent variable, and let's remove something which can affect this two card information. So I'm removing two checkouts, I'm keeping two browse, and I'm removing like purchase form. So, but I'm leaving this interesting potential card total cost. Let's build a model. So there are not a lot of parameters here. Like I'm doing cross-validation because I don't have a lot of information to do a good validation split separately. So let's keep it for cross-validation and see how it goes. And basically, I will talk a bit more then about balance classes. So let's run it. It's pretty fast, even on my laptop, so I can do it small. And what is particularly important for us? So we can check how training performed ideally, but let's take a look at this cross-validation data. So what we interested in is actually in this column. This is amount of cases when we predicted true, that customer is going to go to a car. And look, we have, and this is what it should be, actually.
Can we explain to which industries is this applicable?
It's for any industry which tries to do classification. So this is a typical binary classification, and we try to understand whether you, for instance, work in Develandoo or not, whether you man or woman or.
Okay.
So basically, what we can see, this is called confusion matrix, and we can like understand our errors, the quality of prediction, and we see that we should predict false, but we predicted true over 8 records, and we predicted true over this amount of records. So error is actually quite low, but we need to keep in mind that sometimes we have a like a balance problem. So imagine that we have only, as I remember, 100 and something two-card events inside this data. And basically, all other amount of events are not going to occur. And we basically can build a simple model which says it's not going to occur. And this model would be accurate, very accurate, because like the amount of actually valuable actions is very small comparing to amount of available actions. And we need to treat it right. We need to randomly select reasonable amount of not valuable action to put them together with valuable action. Otherwise, like model would have a lot of noise and is not going to treat problem right. Sometimes it programs, sometimes it's not, but we can derive, for instance, this simple parameter. We don't need this H2O. We don't need to care specifically about the rate of those classes. We can just take balance classes. Sure.
May I ask a question?
Of course.
Yeah, if you could scroll up to the numbers you showed for me the other way. The other way.
Down.
Down as well, yeah. You know, a little bit more. Here we are, the table one.
Yeah.
When I see on the fourth tree, the fourth line here, actually, we see the percentage of wrong alerts, which means true, is only 0.2%. The other is 3%. So we have a factor of 10 between the quality of the prediction. Maybe it's a number of things. But is it true that, do I understand right, that the prediction of true is by factor 10 less good as the prediction of false? Is that when I see this one?
Yes,
correct?
yes. Is that, this is
And why is that, or what is the consequence of such an insight? That if you make a model and see, okay, this is the quality of the model, what is the consequence for your work, or how you assess the predictions?
Down.
Down as well, yeah. A little bit more. Here we are, the table one. When I see on the fourth tree, on the fourth line here, actually, we see the percentage of wrong alerts, which means true, is only 0.2%. The other is 3%. So we have a factor of 10 between the quality of the prediction. Maybe it's a number of things. But is it true that, do I understand right, that the prediction of true is by a factor 10 less good as the prediction of false? Is that when I see this one?
Yes,
correct?
yes.
And why is that, or what is the consequence of such an insight? That if you make a model and see, okay, this is the quality of the model, what is the consequence for your work, or how you assess the predictions?
If we have this error, this is kind of 3% of error.
Yeah, but that is for me, that is blurring. Because if you would extend the true to the same number, just extrapolating the error.
No, it's not. I mean,
is not.
so okay. If we want to make it, for instance, less, we consider this separately.
Yeah.
But for for a customer, we just deliver average. Sometimes you can't explain all the details. You know, if you want to this performed like worse than this, like he don't do it. He just okay. We are 90% accurate in average. So that's the point.
All right. Okay. But okay.
Yes.
I
This is this is important. Okay. Let me
but
see. Okay.
obviously the quality
Yeah,
of the two
let's do the
assessments
following.
is different, isn't it?
Yes.
So you make an average, nice. So this is the
Look.
map of average.
Look for a magic. Let's remove this. Let's not balance classes and see how it goes. Boom.
Okay.
Yeah, let's remove. So now it's different.
Okay, yeah, right, let's understand. So it's even worse now. The error of true is by 28% and the error of false is by, so even less 10. Now we have more than 2, factor 10 power of 2.
Yes.
Is that, so why is that the case? Why is true? Is
No,
it
I'm
just
just-
the number
This is
of
you're talking about a separate problem about like
Mhm.
targeting some specific case, you know. But what I'm trying to say at the end with our marketing case, you know, we are interested about this
Yeah.
and which is this in total. We might be interested to reduce this. We are not actually, so it's more or less fine. Even if it's like, I don't know, 50%, we are more or less fine.
Okay.
Because, you know, we build, if you're trying to predict people who is going to convert,
Yeah.
you definitely get like small number of people because of
Yeah.
because of historical data and because of limitations. What I'm going to do next? So if you have, for instance, only 1,000 people, and you're going to run marketing campaign, and Facebook says you, no, come on, 1,000 is it's nothing. I can't operate this type of audience.
Okay.
What we're going to, you need to do lookalike. And this smooth all the precision
Okay.
into. So we
Yeah, I see.
have our secret magics to balance this, to make it both wider and reach some reasonable accuracy here. It's changing.
But from the 136 true
Yeah.
correlations, 28% may be wrong.
Yes.
Okay, so, okay, good. Okay, nice.
Yeah. But it's good that you're asking.
No, actually, only 3 are wrong. 136 is right, is correctly predicted.
See
The
again.
figures on the main diagonal is correct prediction.
Yes. So this is when we are right.
3,806
This is when we are right. This and this is when we are wrong.
What I see is that on the true line,
Mhm.
you see that the deviation from
Yeah.
the objective is significant compared to the false. And the question is why is
It's also related to the size of the class.
this true?
If you have
Yeah, that could be
class
so the
size.
extrapolation of the class with 100 is to the other class maybe is wrong, but it is at least significantly you measure that. Okay, maybe
But that's
it's
exactly
wrongly
the
weighted.
effect of what you do with balanced classes. So basically, for the prediction model, you take the same amount of targets which are true and which are false, so that the targets are balanced. And then the result is much better because you then have 99% of cases which are anyway wrong.
Let's
I
continue
see that.
after the discussion. Thanks. So basically, and this is interpretability. So this is I just take one root decision tree to see how it performs. And look, I see that like potential card grand total is so important. You could split like true or false, very good. And then I write to Harry, like, Harry, what is potential card grand total? I didn't know. Remember, I had no information about like the whole data, and Harry told me that this is like a historical amount in your card, and this is really important. I mean, you can just, in this case, having only a cluster, for instance, you can build a cluster, like small amount in the card and big amount in the card, and run a campaign. And after that, for instance, we move to this username node, and we can also split usernames, like those who are going to convert here, and those who are not going to convert at the end, and use it as a cluster. And of course, like there are a lot of delays in loading information here, and this page rendering duration is also important. So you're like going to check it at the end if you want better conversion. I can say this for sure. So we can analyze this. Naturally, we have, like, let's take a look at the average variable importance through all the trees. So here it is, what we have. So we have this page rendering duration. Yeah, so here it is. We have potential grand total, very important, a lot of durations, and username, and session. So this, like, it's a good catch with this potential grand total, and I said, Harry, I think we're gonna like make it in our system because it's interesting information that we also need to manage. So, but at the end I realized that we are quite close to New Relic, and with this information, with this pixel, and basically there are a lot of like opportunities for it. So even if you have New Relic, it is possible to make these kind of predictions. I spent only a week on it. And so this is how I can extract information from this node, these users. For instance, so I just extract information about users who are going to convert. Of course, this is like 10 examples, and I made. And let's do a checkout model. Just curious, and basically I just removed this potential information because it's so important, and I'm curious how it goes further with this, without this potential information. If we can make it, like, let's do this, and let's check it out. This time, balance classes are switched off, and basically here it is. Much worse, right? But look, the total cluster of our like probable conversion is bigger. Actually, at the end of the day, because everything is like probability or whatever, but at the end of the day we may get better results here because of the size of the cluster and the amount of users that we are able to capture with like partial attributes, not exact for those who are going to convert, but with partial attributes, and here result might be even better. We need to like take it into account. And let's like experiment again. So we have like 1, 5, 9 here. Let's try to balance classes. And it's worse in this case, but we try to make it better, but for us it's worse at the end. So you never know. Actually, we did kind of automation. We want to try different parameters. to understand that like things go in the right direction. Here is the tree here. So look, we have a lot of sessions, and we have a lot of durations. So now durations are important. Basically, I think that those sessions are somehow connected with durations. This is why it like splits these time. But also, from those sessions, you can extract information about users and your clusters. Session. So without having historical information, duration is important. So I don't know how this synthetic data replicates the real life scenario, but I know New Relic is good about measuring those delays and durations like Relic. Because just because of that, like your conversion obviously can go up or down. And basically that is what I'm going to do is just to shut down our cluster. So that's all from my side. Next, Andres, and then I think
So, well, this case study is going to take 10 minutes, 12 the most. Basically, what we want to show here is an application to an actual customer and how our data science team developed a prediction model for a specific customer. Ready?
Yeah. Did you switch?
You should be ready, yes.
Over here. Yeah, it's on.
Okay. So, thank you, New Relic, Develandoo, for having us here today. I'm Andres Soler, and I'm in charge of business development for Epica. Basically, I want to present a case study of a publisher, a big media company based in Spain. Basically, they have interests in newspapers, magazines, like the typical media company that's struggling into the new digital world with fierce competitors like Google and Facebook, and trying to find new revenue streams and ways to monetize their huge audiences. Because at the end of the day, media companies in any market of the world have really big audiences still getting information, news, sports information, etc. So this is like the background of what Grupo has in Spain. You can see their traffic is interesting, monthly traffic for these sites. And they approach us with a problem. And what we like to do as a startup, which is very flexible, is to approach customers under a proof of concept engagement. And basically, they're receiving for an advertiser very well known here in Munich, BMW, and ask them, look, I'm paying on a pay-per-click basis to Google and Facebook. You're charging me on a CPM, cost per mille, cost per 1,000 impressions, and I need to improve my click-through rates. So here the conversion, this is a publishing, the conversion was the click, right? What their advertiser or their client was trying to tell them is, I need more clicks per 1,000 impressions. Please deliver. Okay, so basically we have this hypothesis that basically we were able to create, based on the data, to create clusters of what we call clickers, and expose this cluster of clickers to the same advertising campaign of a control group. They usually, as you may know, segment their campaigns on a contextual segmentation basis. They say, okay, 1 million impressions of BMW. Okay, what's the target? And okay, put half of those impressions on lavanguardia.com, the news site, on the economic section, and the other half of the million impressions put it on mundodeportivo.com, on the football or soccer section. Okay, and they get their typical CTRs, 0.15, 0.19. And on the other hand, we built a predictive model to be, and we call it a cluster of clickers, and we expose the same campaign, the same creativity, the same amount of impressions, right, to be able to compare. So, very important thing, we had to do an integration. They used the technology they used to deliver their advertising campaigns. It's an ad server, DoubleClick for publishers, now called Google Ad Manager. And our data science team created a prediction model, basically using a binary classification. I mean, we get event data, events like impressions and clicks, right? And we correlated with event metadata, such as device, operating system, location of a visitor, and by analyzing patterns and also building a binary classification model, we were able to build, and with a very interesting audience, we were able to build on these dates a cluster of 7 million potential clickers, right? And this is the cluster that was exposed to the exactly same campaign that, as they usually do, with the regular way of segmenting the campaign, okay? So these were the results. The proof of concept, it lasted 3 months. Basically, that's something very interesting that we're also trying to explain. It sometimes customers want to have immediate results, and we say, no, we need at least a commitment to have a 3-month period, because we had to do some integrations with their ad server. And after that, we had to do iterations. At the end of the day, on the first iteration, we didn't win over the control group. But on the third one, our CTR was 83% above their average CTR. So by using Epica, there's, maybe not this time, but there's, okay, I move here. And Epica, at the end of the day, it's a software as a service platform. We provide access to our customers, to our partners, where we are able to see the data platform, we are able to see the clusters, you are able to see our cluster builder. At the end of the day, what we're trying to do is to provide the possibility to create clusters on your own. And what's more important here is, because at the end of the day, a cluster, it could be an amazing cluster, but if you don't activate the cluster, you're doing anything, right? So the key here is activate the predictive clusters. These guys were activating it via an ad server, which is the tool which they monetize their audiences. But you could activate clusters via digital advertising, Google, Facebook, programmatic buying, personalization of your website, email marketing campaigns. So this is like the key point of Epica. Just to finish and wrap it up, this is basically what Epica is, a summary of what you've seen today, what Epica does. And basically, we try to, based on data, we add artificial intelligence and machine learning algorithms to be able to make accurate predictions. And what's different about our platform? If you're familiar, sometimes people say, hey, you're a DMP, a data management platform. We do the same, what a DMP is capable of doing, yes, but we're not a DMP. Then you're a CDP, because you're able to ingest offline data, CRM data, point of sale data, and also digital data. Okay, we have a CDP capability, but even though we have those capabilities, we're not a DMP nor a CDP. We are a predictions platform, and with these differentiators and the possibility to bring third-party data also, and well, this is. I think this is the case study we wanted to present, and thank you very much. Now we're gonna stay here for a while. If you have technical and data science questions, you can discuss with Andre. If you more marketing.
Platform presentation, so you can.
Oh yeah, definitely. Yeah. At the end of the day, if anyone wants to see the platform. In the real world we're operating, we can set up a presentation or a call or whatever. So thank you very much for having us here today. Thank you for coming, and great to have you here.
Thank you, Andres.